Okay, hello everyone, and welcome to the second day of the fantastic Java Champions Conference. It's my pleasure to introduce today Sandra Parsik. Sandra has been a software developer and consultant in the Java space for many years. She has become a Java champion a couple of years ago, making very good use of her COVID downtime. Just looking at her Twitter feed in 2022, she gave 18 talks, recorded 21 podcasts, made 566 contributions, presumably to GitHub somewhere, had tens of thousands of visitors on her blog. And it's things like that that make me realize how little I have accomplished in 2022. So we're very glad to have her here. And Sandra is going to be talking about Kubernetes development and apparently how to survive in it. I very much look forward to the talk, and I'm sure so do you. I'm going to let you take over from here and remove myself from the screen.
Okay, thank you. Yes, welcome to my talk, Kubernetes Developer Survival Kit. Yes, my name is Sandra Parsik. You can find me on some social media platforms. So I will, and like the pleasure introduction, I will skip the slide. So let's start with a little motivation for this talk. When I start with Kubernetes, this was like a big playground. So you have some kubectl commands on the terminal. Maybe you have a Docker images. You play around. This was lots of fun. But in that point in the time, the management say, "Oh yeah, Kubernetes is very cool. Let's use it in the production." And so my problem started. And at the end, I have to solve many problems, like think about the versioning, what's about container images that's production ready, what's about to make my application Kubernetes ready, how can I see what's going on my cluster, what's about my Git repository, what things should be belongs to it, etc., etc. So many things to think about it. So, but the good news is that at the beginning of the cloud development, some people make some have some ideas how to introduce application to the cloud. It's called two-factor app, and there are hints and practical tips how to do it. It was developed for cloud platforms like Heroku, but many hints we can use for our Kubernetes development. So this two-factor app has a little friendly reminder to talk about what my code base, what about dependencies, config, what about my build process or release process, about operation stuff like what I need for logging, for port finding, and so on. So let's start with the first problem or the first questions. What all belongs in my Git repository? The short answer is that is everything. That means the actual question is how many repositories I need. So when I think about this problem, I have to give you an example how many repositories you can need. So example, you need your application Git repository. You already have it, I hope so, because there's where your Java source code is, where your build script is. And in mine, and maybe there could be put more stuff inside this. Then on the other side, you will have some more repositories, like a config value repository, where you put your configs for your application or for your cluster. So when you have some buzzword in mind, maybe you will think about GitOps. And maybe you need some cluster setup scripts. Maybe your operation will be because you have separate teams that make a whole Kubernetes administration. So maybe they need some cluster setup scripts. So we put it in a separated repository. So we are in the rule of dev. So our important repository would be the application Git repository. So let's see on the sample how this Git repository will run. So our starting point is a Java application. So we have a Spring Boot application. Java 7 is running on Java 17. I'm a team Maven, so I will use as a build tool Maven. So my repository structure will be like, okay, I have a POM XML, I have my source main Java direction structure, and I have, of course, tests, so I have source test Java. So the first question is, okay, I have to put my application in the container images because this is the deployment artifact what we need for Kubernetes. So the question is where I should put my container file. In this case, I will use a Docker file, and I will use the convention of Maven that I have in my structure. So when I have source main Java for my Java code, so I will use source main Docker for my Docker code. So I have a Docker file where my application will be put. In this case, I have a multi-stage Docker file. This could be another one, but this one is, like I say, is a sample. And the next question is how I can build this container images. And the good point is we have a Maven plugin for that. It's called Docker Maven plugin. So I can integrate my Docker builds in my Maven build. So I have, as developer, has my command for the terminal Maven clean package or verify, and it will build my jar file and my Docker container that I can use later on. Of course, I have more alternatives. I can use, when I don't want to use Docker, I can use build packs, Jib, Builder, or Podman. For some kind of some of these tools, they are Maven plugins too. It's not important that you use a Maven plugin for that. The important thing is here that your container image build is part of your build process, and you can execute it locally. So when you don't want to use Docker or want to use something else, and this tooling is not part of your build tool, it's also good to have a script, wrapper build script that call all the tools with one command. That's very important, that the developer can executable this all locally to verify if everything is working. The next point is because as a developer, I'm now responsible for this Docker image or this container image. So there are some good practices that we should follow to have good container image that's production ready. For example, we want to remove unnecessary tools from our image, so I don't need a whole RAM on that. I will only package the one service per image. So when my application is running on more than one service, so I need more than one Docker image on that. I want to build small images, and I want to optimize my build cache. Another point is that I want to use a container registry, like a Maven repository for my jar files, and I want to use for releasing that one tag for one release and don't reuse my tags. And of course, on the last point is to have some security scans on my container images. The question is how I can solve these practices. First of all is to optimize my container images. For example, I have a multi-stage build. That means in the first one, I will use Eclipse Temorium base images that have more Java tools, but that I don't need on production because I want to extract my jar to have many layers, so I can reuse them and on the next stages that based on the distress Java 17 base image. Why I want to use this one? This base image don't have a shell or something like that, so I decrease the possibilities to have some security issues on these images, and I reorder my layer so on so that the build cache can use. For example, the first copy, it's copy the dependencies. There will have release numbers. So the possibility that I change this is very small. So my Docker build can reuse this cache from the local machine on that. So with the time, my build time will be decreased on that. And so I can optimize my build time, have a very small build images, and I have a Docker image for production that have only this stuff what I really needed. The next point is to use a container registry. Of course, when I'm in the cloud, I can reuse container registries from the cloud provider. Azure, Amazon, Google has someone. But when I also on premise, I can use production from JFrog or for Sonatype. Maybe you have Artifactory or the Sonatype Nexus on your company network, so we can reuse them because they support Docker images as a format. So put Docker images into a container registry and use it like a normal bird artifact, how you know it from jar files or WAR files. The next point is to make some security scans. That means, for example, you can use Trivy for that. So Trivy is scanning for some security issues. And a good point is that he's look on your jar files inside and about the stuff what around in the Docker images. For example, here I have some criticals on the libc library, and he gave me a hint which version I should install to fix this issue. So I have very fast feedback on the development when I have some critical issues. But this is not enough. This is only a very small part of this security stuff, because you have to think about containers in your registry. What's about them? Because maybe the container are okay today, but not tomorrow. And you want to have some hints that give you if this is okay or not okay when these containers have some security issues. And what is about containers that already run in the cluster? So maybe you updated your container images every 2-3 weeks. And in these 2-3 weeks, some security issues come up, and your cluster should give you a hint, hey, there are some security issues, you should do it. So this is only a small part what I show. You have to think about what's about the cluster. The next point is about deployment scripts. We want to deploy on the Kubernetes cluster, so we need to write some Kubernetes descriptor, but don't say it's standard, but developers love to use Helm charts because Helm charts is like you combine a template engine with the Kubernetes descriptors, and so you have the whole programmable possibilities that you want to have as a developer. Maybe when you're coming from the operation side, you will prefer another tool because you don't need this possibility of a programming language. So for me, it's very important that it's independent of the tool, that you put your deployment script for your application in the same Git repo like your application is. So in this example, I have my application Git Repository, and I will introduce a new direction structure for my deployment script. So how, when you don't know how Helm charts looks like, here's Snippet. So this is a snippet of a service definition in Kubernetes, and you see with the you can see here just the templating that you have some variable like value service type, and I will use values from outside, and Helm charts help me to build full compliant Kubernetes descriptor. The big questions what I have in all project is, okay, which Kubernetes resource should I care about as a developer? So because when you look on this picture, how many Kubernetes components you have, there are some there I don't care about as a developer, like service accounts, storages, persistent volumes. They are parts of Kubernetes that the admin will be managed for me. But I know what my application is doing, and I know which kind, how the deployment should look like ports, health probes. Should the application run as a stateful set, a daemon set, a job, a cron job, or a normal pod? So I have to organize the left side of this picture as a developer and write some Helm charts that the deployment of my application will create the component on the left side on this picture. The good point is, again, there are some plugins for Maven that helps me to integrate the Helm charts build in my build process. For example, the Helm Maven plugin, so I can put my Helm charts as I integrate in my build. So I have one command to build everything what I need for my application. Again, it's not important that I use as integrated in my build tool. It's important that I have something that I can call with one command that build everything. Again, here it could be a shell script that run my build tool and then Helm packaging. The next point, again here, I need a place where I can put my Helm charts. In this case, I need something like a Helm charts museum. In common, I could use a container registry, but I will have some more comfort, so I will use something specialized like Chart Museum or the JFrog Artifactory or Sonatype Nexus. So let's recap the last slides. So we have now everything in our application Git repository, our application source code, build script, deployment script, one container file. Okay, we don't talk about local test environment scripts, but that will we see later. But wait, but only thing what we see is I see only backend stuff because I'm a backend developer, and front it's something what the other people are doing. But this is a good question. What's about backend and frontend? How I can combine them. So let's recap how frontend and backend is often solved in Kubernetes. So when my user uses my application, his request will go to an ingress. Then I have a front-end service that is responsible to balance the request to my pod where my front-end container is running. And then when he is talking about my backend system, then I have a backend service that he will separate it to some backend container. And the question is how I can write my deployment script or structure my whole stuff. The possibility is that I have one Git repository with two directory where one directory is responsible for front end and one for back end. And I have on the root directory some scripts that will wrap the whole stuff front end and back end. It's very important that you don't try to use Java build tools to build JavaScript application. It's very good practice that every ecosystem can use their own tool, and so you need a build wrapper script that had the specialized build tools on that side. In this case, maybe you want to deploy front-end and back-end separated, so you need some separated deployment scripts. And the question is which kind of deployment script deployed which Kubernetes resource. So in this case, maybe Ingress front-end service fronted for in one deployment script, and everything what's about the backend is coming to another deployment script. But maybe you will say, okay, I want to deploy always both front and backend at the same time. So maybe it will be better to have one deployment script. That means one Helm chart that deployed everything on that site. The next big question what I heard about is what's about versioning. My hint is on that side, or advice is that start very simple. I use the same version number for my artifacts, so I can see on the version number which artifacts can combine with another artifacts. That means in our application, when I have some npm package Docker images for the front-end Helm charts, they will have the same version number like my jar package or my Docker image for the backend. That's very simple, and it's wrapped, I think 80% of our use cases, because many companies develop application that is running on their own hardware. And of course, when you have products like Keycloak and you have to maintain some Helm charts for outside of your company, then of course this hint will be not cover your use cases. But think about it at first to start it simple, and when you have some problem on that, then you can change the version structure. Next point is about local development environment. So of course, when I have a Kubernetes cluster for my own, I can play with it around, but I don't want to make for every test a git commit and push and wait till this is on the Kubernetes cluster. Maybe I want to test it locally, and I want to have something locally that I can develop my deployment script. Because when I testing my application, sometimes I don't need the whole Kubernetes cluster. So because sometimes it's enough to run a Docker container on that. So let's see on the first point how I can test my application locally. I liked to use Docker Compose for this stuff and the Spring Boot Maven plugin when I developing with Spring Boot. So I have on my Git repository a Docker Compose file where I can define my servers that I need. In this case, for example, MongoDB, and I can define the Spring Boot Maven plugin and configure it to use this MongoDB locally. So on my shell, I can start my Docker Compose file with Docker Compose up. So he will bootstrap my MongoDB. Maybe when I make front-end development, I can put the backend in the container too and start the container for the backend also. So I have everything locally to test my front-end on the machine. And when I only need the database, I can say, or the one service of this Docker Compose, I can say, hey, Docker Compose up database. So one service is started. And Maven Spring Boot run will start my application, and they will use the MongoDB. So I have without container magic everything on my machine can use to test my service locally. So how I'd show you in the example, I can use the Docker Compose file to define the backend stuff, and I need it for front end. So I have everything I need without Kubernetes magic locally to run this whole stuff. The question is, okay, database is very easy, but what about other dependencies? Maybe you have to call some REST calls and so on. So the secret is to use mocking, like a mock server. So I can introduce in my Docker Compose a mock server service, and a mock server has the possibility that you can define some expectation. So when I have a HTTP request on a special path, I can define which kind of response he will get back. So I have so I don't need to bootstrap everything on my local machine, so I can cut the direct dependencies on that. The next point is how I can developing my deployment scripts locally. The answer here is Minikube. Minikube is a single node Kubernetes distributor that is based on Docker images. So I can bootstrap on my local machine in Docker container Kubernetes. This is not a full plane, but for application development, it's very often enough to use it. So when I have to develop some Helm charts, I can do it locally and do it against the Minikube. The important point is that you need some config values that that's for the Minikube is for the local development, but this is a kind what you can put this on in your Git repository too. So you will have you can see it later. You have a local value YAML where you can define everything for the local development. So you can see an example. I have an Ingress YAML, and I have to configure the Ingress host, and I can do it. Here you can see it, the dashboard. So you can see that's the whole Kubernetes. So you can do everything you need. You can have the same tooling what you're using in production. And when you go back, you can see the local value YAML where I can define the local host or the host name that it's showing on the Kubernetes. Now I have everything that I need to run the Helm charts against the Minikube. Of course, there are many other tools like Minikube, because the problem is when you develop against Kubernetes, you have a standard RP for the Kubernetes components like the Ingress, but you have many different implementation like Traffic or Nginx. So, for example, Minikube use as a default implementation for Ingress Nginx, but maybe you want to have as an Ingress implementation Traffic on your production Kubernetes. So, of course, you can configure Minikube, but if you don't want it, you can look on other single nodes Kubernetes descriptors like K3s or Kind or Micro Kubernetes. They have other implementation as a default, so you can choose this one what you need for the or match your requirements. The next point is about configuration. So I have my whole application. I can develop my deployment script, but you will have many stages to production, and of course you will have different configuration in every stage. So the question is how I can configure it. In this case, again, the 12-factor app can help us. And when you look at the 12-factor app, you can see the hints, store the configuration environment variables. And the question is how I can do it in Kubernetes. The first point is you have to prepare your application for that. So the good point is Spring Boot help us. So I have my application properties where I can say, hey, please use for this property the value of my system environment variable MongoDB URI. And when you don't find this system environment, then use the default value. Of course, you can discuss in your team if it's good to have default value. Every team has her own opinions and arguments to do it or not to do it. So I have to find out in your team what to do, what's the best way for your team. Some people are saying, hey, I want to fail fast, so default values are not good. Sometimes it's good to have default values, so you have to find your own way. When you prepare your application, you have to adjust your Helm charts. So you want to define the system environment on the Kubernetes cluster. For that, you can use the Kubernetes resource config map. So you say, okay, I need config maps where my system environment MongoDB URI and MongoDB enabled are inside. And I want to make this configurable outside my Helm chart. So I have to introduce a Helm chart variable values.mongodb URI and MongoDB enabled. And the next point is how my deployment can consume them. So for that, I have in my deployments descriptor, it's possible to say in my containers, hey, please use the environment from the config map preferences. So I put the name of my config map in this as a config map preference. So Kubernetes know how to use, where to find the system environment. And the last point is I need a value YAML where I can define my values for this variable. The next point, how to manage this configuration. As I said in the very beginning, it's too good to have a config value repository. And in this repository, I put my configuration for my application. The question is how can I structure in this repository the whole values? I'm a big fan of the left side where I can work with branches. That means every stage in the reality are represented by a branch. So I have a branch dev, I have a branch pre-prod for the pre-prod, and a branch for a prod. And inside of this branch, I have the values that it's that shows the current configuration of my cluster on that side. I know some teams are not very familiar with Git commands and something like that. I don't like to work with the branches. They maybe have a flat structure on this. So they represent the stages with directories in one branch. So I have a dev directory, a pre-prod directory, and a prod directory. Why I'm a fan of the left side is because now I have possibilities to have to give better permissions. So maybe the Kubernetes administrators say, hey, what's going on dev or pre-prod? It's your business, developer. You can do it by yourself. I don't need to look at it. But for us, it's very important what's going on the prod. So maybe you can say, okay, I protect the branch prod, and everything should have to go with pull requests on this prod, and what's going on dev, the developer can do it by his own. This kind of permissions, you cannot do it on the right side because dev and prod are in the same branches. So you have to protect the whole master branch, and you have every time to talk with the Kubernetes administrator. That's when you want to make some experiments on the dev stage. So this is the reason why I'm a very big fan of the branch strategy on that side. The next point is about secrets. Of course, when we talk about configuration, there are some configuration stuff that it's like password certificates and so on. The best solution would be to have a secret manager like a HashiCorp Vault, or the cloud solution like Google Secret Manager, AWS Secret, and so on. The problem is when the team started with Kubernetes, they have to learn so many stuff. So to introduce the same time Vault could be a brain blow on that side. So, but you don't want to have the secrets plain in your Git repository. Therefore, my recommendation is when you started with the whole stuff, keep it simple again. So maybe the Helm secret plugin could help you. That means, everything is in a Git repo, but the secrets are encrypted. So you have you need some decrypt keys when you deploy it on production on its side. So the Helm secret plugin depends on Mozilla's soaps. So you can say, okay, Helm secrets encrypt and decrypt, and when you make the Helm the deployment with Helm, you have to give him a hint. Hey, here are some secrets that you have to decrypt before the deployment. So this is, I know this is not the best solution on that side, but when you have so many things to do and want to keep your life simple, so this is, I think, a good step in the right direction to do it, to handle with the secrets. It's better than to have this whole stuff plain in the Git repository. So now we have everything what we need to deploy to the Kubernetes and run on Kubernetes. Next point is we have to make our application Kubernetes ready. So there are some good practice hints for application container. This practice we need also for application on Kubernetes, but we have to have more stuff. For example, health probes and readiness probes. The good point is on that side that when you use Spring Boot, that Spring Boot can give you out-of-the-box configuration or settings that helps you. For example, logging message should be on the stdout. That means, of course, you can start to configure your logging framework because you don't like the standard logback from Spring. By my hint on that side is you have so many things to do. Make your life easy. Use the Spring default logging settings and the default logging framework, and use your time to solve all our problems, because that's not the important stuff on the whole story. So my hint on the side is use Spring default logging settings. That's okay. Next point is that we need some application monitoring. Again, Spring can help me here. So I can use the starter actuator, and for example, I want to use a Prometheus. So I configure Spring Boot that he should enable it, and so I will get some metrics for application monitoring out of the box with also only a few lines of configuration, and I have the basic metrics like how many HTTP requests are going on my application, so on. And when I need some metrics, custom metrics, I have enabled the Micrometer library to do it by my own, and I can start it, so I don't need to configure it by myself. The next point is I want that my application can start and stop robustly. So again, here Spring Boot can help me. So I can introduce the dependency Spring Boot starter actuator and enable the endpoints info and health. The good point is that Spring Boot recognized by itself that it's running on Kubernetes. So I only have to configure my my deployment descriptor to say, hey, please use the actuator health liveness for the liveness probe, and the readiness probe can you find on the actuator health readiness. And this is everything what's coming from Spring Boot by itself, so I only have to enable it. The very important stuff is here, you have to secure these endpoints to the outside of your cluster. These are information that are only needed inside your cluster. You don't want to give it outside. So you have to go to your ingress and say, for example, when you use a Nginx ingress controller, to say, hey, everything, every request on the actuator outside the cluster should be denied. So then you have can use it without authentication inside the cluster, but it's secured outside the cluster. The next point is continuous integration. the question is how I can introduce in my continuous integration. Many teams are using Maven builds or Gradle builds to build the jar. And so now we need some more build artifacts like the Docker container and Helm charts. Again, here, the 12-factor app can help us with a hint. We should separate strictly build and run phase. And the questions how I can do it. The first one is the build phase. So I already have maybe a build job in my GitLab runner, CI, or in Jenkins or Bamboo, or which kind of CI server you use. And every time when I make some changes on my Git repository, a build job started. And now I have to extend it that I don't only build some jar files. I want to build some Docker images and Helm charts too. So so the result of my build job will be some Docker images in the container registry, Helm charts in my Helm chart repository, and jar files in my artifact repository. Of course, with the jar file repository, we can discuss because the deployment artifact will be a container and the Helm charts, the deployment scripts as a Helm charts. So, but maybe there are libraries too. So then you will need the Maven repository also. Next point is about run. So that means deployment. So how I can deploy my whole stuff in to the cluster. There are two possibilities. One I call push deployment. So that means that it's outside the cluster. So maybe make some changes in my config value repo, or another trigger event, and a deploy job is triggered. So he's looking on the config values. He's collected the Docker image and the Helm charts from the repository and deploy the whole stuff on the Kubernetes cluster. When I hear about GitOps, they always say, hey, you have to do it inside of the Kubernetes. So you have a Kubernetes operator. So he is looking on changes, what's about your Git, and he's doing it inside the Kubernetes cluster. My opinion is that, it's very cool to have everything in a Git repo. And I think it's very important to have the only true in a Git repository. But it depends on your organization, on your team, which kind of deployment is better. So maybe you have some restrictions, so a pull deployment is not possible. So but it that doesn't mean that you cannot do GitOps. For me, GitOps means that the true is in the Git repository and not how the deployment is doing. So don't be worried about that you cannot do a pull deployment. I think the important message is here that the truth is in the Git repo and not how you're doing the deployment. So now we have everything in the cluster, and the question is, hey, how I can see what's going on the cluster? Of course, I can use kubectl plain on the command line. So with the kubectl describe pod or get pods to see what's going on, but maybe that's too rudimentary and too much of typing to see what's happened. So maybe you want to have another tool, but stay on the CLI. So K9S is, for example, a good CLI tool to give you information about the cluster, but in more fancier stuff. So you can, it's like a little bit like Total Commander. So you can look at the cluster, what's happened, and stay on the command line. So maybe you're not a command line fan, you're more to have more better UI experience. So don't worry about it. There are another tools. It's called like Kubernetes Lens. So you can manage many clusters with this tool and look at that without going on the dashboard and stay on your machine to look what's happened in your cluster and do stuff. Of course, this is very rudimentary. It's only helping for the developers to what's going on. That's nothing with application monitoring. It's not about operation. It's about, for me as a developer, to look at the cluster, what's happened, or do some developing step manually to see what's happened with my application on the cluster. The last point is what's up debugging, and this is it's complicated than in the normal when I started my application on a Tomcat as a jar file, because I have many layer what I can debug. This picture shows very good. It's okay that you don't see everything. I put a link on it. You can, but it's demonstrate how complicated it is. So you have to think about, okay, my application is not started. Maybe it's because of not well configured Kubernetes components. So I have some hints. Okay, what I should check on Kubernetes to find out if the reason really the application that make this error. And when I have my application, so maybe I have to debug my pods, my services, my init container. What's about, maybe it's running when I use it as a plain Docker container, but it's not running in a pod. So I have some hints and debug possibilities to find out what's happened. The very good point is that with a newer Kubernetes version, we have the possibility to introduce a debug container, because like I said at the very beginning of this talk, it's very good to have a very small build images. That means you don't have a shell when you run on production. So you have to possibility to connect a debug container where is a shell, so you can see look at your original container, what's happened on that side, without to install a shell. So you save some time. This kind of debug container is possible since the version 1.23. So look on the version of your Kubernetes of if this is possible or not. So I hope I could show you some hints, some solutions. Of course, they are not silver bullet, but I hope it helps you to think about a solution for your problems in your project about this Kubernetes stuff. So we see what's about that's for every question of that, or every problem that we can have a configuration container image. There are solutions. There are possibilities to make it even our life easier. So this so the travel with Kubernetes will not be a hell trip from that side. So now we have some time for questions, I think. Of course, the slides you can find on my GitHub repository. You can find me on Twitter, and of course, write an email. But I think now we have some time for questions.
Yeah, thank you very much for that talk. So that was super informative. And so I certainly learned something practical. I really like that hands-on, step-by-step approach. So there's only a few questions. I guess it's still pretty early in the United States, and people are not woken up. And
yes, I think you're 6 hours behind me.
Right.
So we have afternoon here in Germany.
So here we have a question. What do you think about the learning curve for a new component service to be deployed in a platform with Kubernetes? So what kind of things have you found that helps a dev minimize that learning curve?
Not really. The marketing promise was that Kubernetes will make our life easier. Yet maybe it make it life easier when you have Google problems. But on the other side, you have to learn more new stuff. So it's not about, okay, I'm a Java developer, I know Java code and I can write my Java application. Now I have to learn about how is Kubernetes working, which kind of resources I have, what's about networking, and so on. So we have some skills that are a little bit more operation stuff. They are left shift to the development, so we have to make some. You have to think about it, how to solve it. So maybe it's solve some problems for us, but Kubernetes introduced new problems to us. So we have the same amount of problems. They are only different.
Okay. So what this person asked specifically is, do you recommend that people do a pet project? Should they are there training courses that you recommend?
Yeah, also it helps me to read about Kubernetes from the administration side to learn which kind of resources. Of course, I don't need to admin a storage volume or so on, but it's very good to know how it's work when I develop, and so I want to go step by step. So it's okay to have a playground to play around with kubectl, and then you started with the whole automation stuff. So yeah, that's for me it was very helpful to read at Kubernetes admin book about it. I can recommend Kubernetes in Action and do the certification of the Kubernetes application developer. But that helps me to go deeper to the stuff. But maybe it's you can do it by your own. You don't need to do a certification.
So
I hope it.
Yeah. Then Kirk Pepperdine, I'm our very own Kirk here. I'm leaving off his strongly worded comments, but here he does say, in his opinion, Kubernetes it's not that any part is that complex, but the number of parts and the fragility of it scare him. So he says the project where he spent days just setting up the build. So is in your opinion, is that fatal? Will it get easier? Will the tools get better? I mean, it should be plausible that at some point, if everyone has to do the same things, that the tools would lose their complexity.
You can see in on Kubernetes ecosystem what we see on every ecosystem. When we have a complexity problem, you introduce a new abstraction and to hide this complexity. The problem is everything is working in the happy case, but when you go in trouble, you have to go to every abstraction layout to find the problem. So I don't know if this is a good way, but you can see in the discussion, many teams are going back from microservice architecture because of the complexity to monolith, and want to find a trade-off on that side. And the next point is we have Kubernetes distribution like Ranger. When you have managed Kubernetes on RVS, it's a little bit different, like a Kubernetes in Azure. So it's like with the database provider, Oracle database. We have a SQL standard, but an Oracle database is sometimes working different than a PostgreSQL.
Okay. So another question, also by Nacho. What do you think about giving developers access to Kubernetes clusters, security versus autonomy, and also having a local? Do you think we need?
Okay. I don't want to have access to production, but I want to have some application monitoring stuff like logging or metrics, what's happened. And when some trouble on the production, I want to look with a Kubernetes admin on the side. But on the developer stage or testing stage, I want to have full access to it to find better how I can develop the application the best for the Kubernetes. And of course, when the stages are gone near to the production, it should be the permission should be less for development. Of course, when you're doing DevOps or what we call DevOps, then the whole team should be. But as when I look at my dev rule, I don't want to have permissions on the production. That means with the power, there are some responsibility, and sometimes I don't want to have this responsibility.
Okay. So Kirk he can't ask a question, but he must make comments. It looks like there's at least a year's worth of learning at minimum. Do you think that's an exaggeration? So in your opinion, how long does it take your typical Java developer who has not used Kubernetes before to become a productive person?
I have 2 years ago a greenfield project. There were only 1 or 2 persons have some experience with Kubernetes. It takes us 6 months till we run productive with Kubernetes, and we find with the time we find many issues, and we do better because you do your best when you started, but there are so many things to learn with Kubernetes, so you have to improve it. And then a new Kubernetes version is outside, then some resources are duplicated, change it. So this is, I think you a good Java developer that can develop Java application we need at least 6 months to go to production, because there are so many stuff to learn.
All right.
Of course, and when you see talks, they're very easy because they have a very simple application, but in project they are a little bit complicated.
Okay, well, that gets us to the end of the questions, and there's a bunch of people who say great presentation. I'll second that. And we're just 2 minutes away from closing time. So thank you very, very much. Are there any final slides that you wanted to show, or are we done?
We can stop here. Okay.
All right. Well, thanks again. And so I hope everyone has enjoyed the talk and can now go on to the next thing on time. And yeah, sorry, my kids are just coming home and
okay.
Not realizing that we're online in front of thousands of developers. All right.
Okay,
so
have a nice day.
Same to you. Bye-bye.
And enjoy the conference.